In our last class, we discussed the idea of percent change as being a percent of increase or a percent of decrease and how we can work through problems with that. So we'll start the video in reviewing percent change, and then we're going to spend the other part of the video learning a little bit about simple interest. And so as we go through percent change, you may want to take the opportunity to do some practice problems that I present in the video. And as I discuss simple interest, I'm going to encourage you to take some notes so that you can approach the problem on your homework calendar, as well as be ready to complete problems in class that will deal with simple interest. As you can see, simple interest is described as a percent of increase or a percent of decrease. And simple interest is considered to be something that is collected on loans or earned on investments. And simple is not commonly used in the sense of simple interest, as most banks and credit card companies calculate interest using compound interest, but you don't need to worry about what that kind of means at the moment. Last week, Miss Snail walked an average of 55 feet per day. In an effort to increase her cardio activity, Miss Snail has walked an average of 70 feet per day this week. What is the percent change of Miss Snail's walks? So we're going to set this up thinking about that same proportion we used in class earlier in the week, and that's going to look like this. So with this proportion, we're going to go ahead and try to find the information that will help us fill in the missing parts. So we're looking for what is Miss Snail's new average each day, and what is her old average, or compared to her old average. And then we're also going to compare percent out of 100. The 100 always stays the same, as we have discussed many times in class. So if I take a look here, I can think about that I have 55 feet per day from last week. So that's going to be my old information. And I have an average of 70 feet per day this week. So that's going to fall into my new information. So if I go ahead and take a moment to set this up, I see that last week I was at 55 feet per day, and this week I'm at 70 feet per day. And what I'm looking for is the percent change. So my percent is what I don't know, and I'm going to be solving for that value. We discussed in class that the easiest thing for us to do is really to think about cross multiplying and then dividing. So with that, I'm going to go ahead and say that I have 70 times 100 equals 55x. And so 70 times 100 will give us 7,000 equals 55x. To get x by itself, we're going to divide both sides by 55. We see, of course, that this allows for me to cross or cancel out 55 divided by 55, and I'm left with 7,000 divided by 55, which gives me 127 2700s, but that 2700s repeats for quite some time, equals x. Excuse me. So I've just solved and found out that 127.27% is my found percent. And when I'm changing or thinking about this idea of the new distance walked every day compared to the old distance. But I haven't answered the question as to what that means for percent change. So in class, we talked about that we're going to take our percent and we're going to subtract 100 from it. So if I take 127 and 27 hundredths, or 27 hundredths repeating, and I'm going to subtract 100 from that, I'm going to find that, of course, I do get a positive answer, 27.27%. And that's going to indicate that I have a percent increase of 27 and 27 hundredths percent compared to last week's walk for Miss Snail. In the next problem, Mr. Snail is an active guy. This week he has averaged 93 feet per day compared to last week when he walked an average of 105 feet per day. What is Mr. Snail's percent change? Go ahead and approach this problem the same way we did for Miss Snail by setting up your proportion of new over old equals percent over 100. As you do your problem, please pause the video so that you can check your answer in a few moments. So I'm going to set this problem up the same way by using my new over old compared to percent over 100. And so I find that the new average for Mr. Snail is 93 feet this week, and his information from last week was going to be that 105. So 93 over 105 feet compared to x over 100. So if I go ahead and cross multiply, I have 93 times 100, and that equals 105x, and then solve. So my x is going to equal 88 and 57 hundredths percent. But I have to remember that I'm not done with this problem, and that means that I need to subtract 100 from 88 and 57 hundredths, and that gives me a negative answer, negative 11 and 43 hundredths percent. That indicates to me that Mr. Snail has decreased, or has a percent decrease in his activity this week, which really makes sense because 93 is less than 105. So his rate went down from his old rate, or his old distance traveled. So if you are still having a difficult time understanding percent of increase or percent of decrease, I encourage you to check out other videos, do a quick search, and find some other problems that you can practice with. We will do a little bit more practice in class the next time I see you, and then of course the rest of this video is going to focus on simple interest. Okay, so moving on to simple interest. This is the idea that you borrow money, or somebody borrows money and agrees that they will pay some interest, and that interest is usually calculated on a short-term loan, often within a couple of years of time, and it's calculated on a yearly basis. So we're going to start with a problem that I think we'll be able to understand, and that problem is Amy borrows $3,000 with an understanding that she'll have to pay 6% in simple interest. How much will Amy owe when she pays her loan back? So on the surface, this looks a lot like a regular percent or percent problem where we're trying to find out how much is she going to have to pay. So this takes us back to thinking about our is over of equals percent out of 100. And so if I look back to this problem, Amy's borrowing $3,000 and she knows she has to pay 6% in simple interest. So if we look at that problem, we can rewrite this problem and basically say, I want to know what is 6% of $3,000. So I'm going to write that down. What is 6% of $3,000? And with that translated, we can now use our proportion pretty quickly. So I know that I see that this is 6%, so I'm going to put 6 over 100. And I'm trying to answer the what is. So I don't know my is, but I know that my total, or my whole, is that $3,000 loan. And so with that now, I'm able to go ahead and cross multiply so that I have 3,000 times 6 is equal to 100 times x. And so if I do 3,000 times 6, I'm going to see, or hopefully realize, that I'll have 18,000 is equal to 100x. In order to solve for x, we'll backtrack or undo by dividing both sides by 100. And find out that I am going to have x is equal to 180. That's $180. So $180 is 6% of $3,000. And so if we go back to our problem for just a moment, excuse the scroll, it says, how much will Amy owe when she pays her loan back? So this question's a little bit tricky because it says, well, how much is she going to owe? She's going to have to pay back not just that $3,000, but her loan itself plus that simple interest. So the loan was $3,000 plus the simple interest amount, which was $180, meaning that Amy's going to owe somebody, whomever she borrowed this money from, $3,180, as long as she pays it back on that year mark. So this next slide is going to discuss the idea of, well, how much will Amy owe if she takes 3 years to pay back her loan? So remember, it's still simple interest with, I lost my pen, 6% out of 100 equals whatever that amount is out of that $3,000 she borrowed. I'm not going to solve this again. However, we know that X is now $180. So if she takes 3 years to pay back this loan, the reality is that it's not $180, it's $180 per year that she is going to have to pay back. So now she would have to take 180, multiply that by 3. 180 times 3 gives me $540. Now Amy owes $540 in interest, except for that we have to remember she also owes that $3,000 amount. So $3,000 plus the $540 is going to give us our amount of $3,540. Let's try another one together. George borrows $7,000 from an uncle to buy a new car. His uncle is charging him simple interest of 4% and has told George that he must pay the loan back in 4 years. How much will George pay in interest, and what is the total amount George will pay his uncle after the 4 years? So reread this problem to yourself and then go ahead and set up what we know based on our is over of equals percent out of 100 proportion. Hopefully you have set up that you are looking for the part, or the is, what is 4% of $7,000. And so your proportion looks like what I have on the right hand side of the slide. X over 7,000 is equal to 4 out of 100. You can go ahead and solve for X by cross multiplying and then dividing, and you should end up with X is equal to $280. That's $280 per year that George is going to owe his uncle in interest. In order to determine what he is going to owe in interest after 4 years, George is going to have to take $280 and multiply that by 4 to know that his total is going to be $1,120 in interest, in addition to paying his uncle back that $7,000 loan for the car he just had to have. So at the end of 4 years, George is going to pay his uncle $8,120. If you completed the problem that's on the screen and have an answer of $200, you have been successful. So after a while, you might begin to think about the fact that simple interest, when calculated, probably isn't done using these ratios and proportions, but rather that there is actually a rule. And so the rule for finding simple interest is considered to be the principal multiplied by the rate multiplied by the time is going to give us interest. So that means the principal is the amount of your money that you borrowed. So whatever amount of money you borrowed. The rate is considered to be that percent, but you must change this to a decimal. And then the time is the length of time that you have borrowed the money. And that amount or that value has to be represented in years. So as long as we're talking about 1 year, 2 years, 3 years, you just use the whole number. If somebody were to say that you're going to expect to be paid back in 30 months or 42 months, now suddenly you have to worry about how you're going to convert that month value into a year equivalent. So I would encourage you to rewind or look back at your notes and try to solve these couple of problems with simple interest using the rule, now that we have a little bit of an understanding of what it means to have to pay interest on a borrowed amount.